Have you ever pondered on the intricate details of the surface of solids? How scientists manage to characterize these surfaces so accurately? A key player in this field is X-ray photoelectron spectroscopy, or XPS. XPS, also known as electron spectroscopy for chemical analysis, is a form of spectroscopy that is highly sensitive to the surface of solids. It's an instrumental technique used to quantitatively determine the elemental composition of a solid surface, and to study the electronic structure and dynamics within atoms and molecules. The discovery of XPS is a fascinating journey that began with Heinrich Hertz. Hertz observed that ultraviolet irradiated electrodes emitted more sparks, a phenomenon that would later be explained by Albert Einstein in his theory of the photoelectric effect, for which he was awarded the Nobel Prize in Physics in 1921. Fast forward to 1967 and enter Kai Siegbahn. Siegbahn used an ultra-high vacuum spectrophotometer to observe photoelectrons generated by X-rays. His work was so revolutionary that he received a Nobel Prize in 1981. Siegbahn named the newly discovered technique electron spectroscopy for chemical analysis, a term we still use today. But how does XPS work, you ask? In XPS, a primary beam, an X-ray photon, is irradiated on a sample surface. The inner shell electrons, specifically K and L electrons, absorb the energy from these X-rays and are ejected in the form of electrons. This is what we know as the photoelectric effect. The kinetic energy of these ejected electrons is then recorded by the spectrometer. This energy, denoted as EK, is calculated using the equation EK equals HV minus EB minus Fi, where HV represents the energy associated with the incident photon, EB is the binding energy, and Phi is the work function of the instrument. So, to recap, XPS is a powerful tool for characterizing the surface of solids. It was first discovered by Heinrich Hertz, further explained by Albert Einstein, and refined by Kai Siegbahn. It operates on the principle of the photoelectric effect and records the kinetic energy of ejected electrons. With this information, scientists can accurately determine the elemental composition of a solid surface and study the electronic structure and dynamics within atoms and molecules. This has been a brief overview of XPS, a remarkable technique that continues to shape our understanding of the world at a microscopic level.